Okay, so this is the last ECA review. So chapter 1 goes, write a word or phrase for the algebraic expression. So 7 subtracted from A, or A minus 7. So you could say 7 subtracted from A minus 7. Or you could just say 7 less than A. Okay, write a word or phrase for the algebraic expression. So you could say 3 times A plus 6, or 6 plus 3 times A, or something like that. Okay, write the expression, the product of 6 and y minus 7. So the product of is going to be 6 times y, and then minus 7. Okay, graphing. Okay, so first I want to find my x-intercept. So I could add 49 and get x squared equals 49 square root. So x equals, remember we have to have a plus or minus when we square root an x squared. So plus or minus 7. So my x-intercept is at plus or minus 7. Okay, now let's find my AOS. So for this, my A equals 1, my B equals 0 because I don't have a BX, and my C equals negative 49. Okay, so AOS equation is negative B over 2A. So we got x equals 0 over 2 times 1, so 0 over 2, so my x should equal 0. So my AOS is going to be a dashed line at x equals 0. Okay, after AOS, I want to find my vertex. I find my vertex by plugging my AOS into my original equation. So I need my original equation. I can change, since this is a 0, I can change that to a y. So it's going to be y equals x squared minus 49. Okay, so to plug the 0 in, we'll get y equals 0 squared minus 49. So y equals negative 49. So my vertex is I'm going to say that's around negative 49. Okay, my next step would then be to find the y-intercept. But I already found my y-intercept because that sits on my y-axis, so I don't need to do that. Okay, I have 3 points, I need 5, so I'm going to make a t-chart. Looks like I can plug 1 in and see what I get. So I'd get 1 squared minus 49. So y equals 1 minus 49, which is negative 48. So my point's going to be at 1, negative 48. Okay, if I'm 1 away from my dashed line, I go 1 away on the opposite side to my dashed line. Okay, so if I wanted to know what the solutions are, if I'm asking for the roots of this, it's going to be where it crosses my x-axis, so at positive 7 and negative 7. Okay, if you wanted to just graph based on looking at this equation, so if the equation was this y equals x squared minus 49, since the x squared is positive, we know it has to look like this, like the happy face. Okay, we know that to find our y-intercept, we have to plug in 0 for x, so we know our y-intercept is going to be at negative 49. So we can get the kind of gist of the graph based on that. Okay, so this one, if I want to find my x-intercept, I add 75. So I'll get 3x squared equals 75. Divide by 3, x squared equals 25. Got to square root both sides, so x equals plus or minus 5. So at positive 5 and negative 5. Okay, so based on this, let's rewrite our equation. So y equals 3x squared minus 75. Okay, based on this, it's positive, so we know it's going to look like a smiley face. Okay, so I also want to find my, if I was just doing the general graph, if I wanted to find my y-intercept, I would plug in 0 for x, so I'd get y equals negative 75. So I know it crosses my y-axis at negative 75. So my general graph is going to look like this. Okay, this one, let's see. So I take x squared plus 1 equals 0, subtract 1. So x squared equals negative 1, square root both. we get no solution. Okay, so that means we don't have it crossing my x-axis at all. So now let's rewrite our equation. So y equals x squared plus 1. Okay, if I try to find my y-intercept, I know it's going to, if I plug 0 in for x, it's going to be at 1. So it's going to cross my y-axis at 1 here. Okay, and I know it's going to have to be a smiley face because this is positive. So I know it's going to go up like this. Okay, if you need a more in-detailed graph, you have to go based on your AOS and your vertex. So AOS equals negative b over 2a, and your vertex is whatever your AOS is plugged in. Okay, so this one, we need to solve. So I'm going to find my AOS first. So if my A equals negative 1, my B equals 3, my C equals negative 6, because we got y equals negative x squared plus 3x minus 6. Okay, so AOS is x equals negative b over 2a. So I got negative 3 over 2 times negative 1. So x equals negative 3 over negative 2, which is 3 over 2, which is 1.5. Okay, my AOS always looks like a dashed line, so I got a dashed line at positive 1.5. To find my vertex, I got to plug my AOS into my original equation. So we got y equals 1.5 squared plus 3 times 1.5 minus 6. So I got 1 equals 9 over 4 plus 9 over 2 minus 6. And if you put this in your calculator, you should get 0.75. So my vertex sits on my dashed line at 0.75. So about right there. Okay, my next step would be to find my y-intercept. So I'm going to go ahead and erase this so I have some room. So y-intercept, you plug in 0 to your original equation. So y equals negative 6. So it crosses my x-axis at negative 6. Okay, I can mirror, so I'm 1 away, I go 1 away again. And we can already tell that it's going to go down like this. Okay, if you need another point, you do your t-chart, and it looks like you could plug 2 in, and then you plug 2 into your original equation to figure out your next point. Okay, graphing inequalities. So let's graph this one in gray. So I start at negative 1. I go up 2 over 1. Or I could go down 2 left 1. Okay, it is a dashed line because the inequality does not have a line underneath it. Okay, to figure out what side I shade, I plug in 0, 0. So 0 less than 2 times 0 minus 1. Is 0 less than negative 1. 0 is greater than negative 1, so I'm going to shade on the opposite side of 0, 0. Okay? Now let's do the next one. So I go up 3, I go up 1 over 1, 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 down 1 to the left 1, because it has to be positive. Okay, and this is also a dashed line because it doesn't have the line underneath. Now I plug in 0, 0, so 0 less than 0 plus 3. Is 0 greater than 3? It is not. So I got a shade on the top side of this. Okay, so actually the spot that they double shade is in this area right here. So that means all of those would be my solution because they both share that. So if I plugged in any of those points into these two equations, you're going to get both equations to be true. Oops, this is probably supposed to be a less than. Okay, so let's graph this one in black first. So I start at negative 1. I go down 1 to the right 1 because it's a negative. Or up 1 to the left 1. It has to be decreasing because it's a negative slope. Okay, it's a dashed line because it doesn't have the line underneath it. If I can get it there. Okay, to figure out what side it's going to shade, you plug in 0, 0. So 0 less than negative 0 minus 1. So is 0 less than negative 1? It is not. So I do not shade across 0, 0. I shade on the opposite side. Okay, the next one. I start at 2. I go up 1, over 1. Up 1, over 1. Up 1 to the right 1. Up 1 to the right 1. Okay, or I could go down 1 to the left 1. Okay, this is also a dashed line because my inequality doesn't have the line underneath. I could plug in 0, 0. Is 0 greater than 2? It is not, so I do not shade across my 0, 0 spot. So I'm going to shade above it. Okay, so my area that they share now is this spot. So any of those points, if I put them into my equations, they'll be true for both of them. Okay, y is less than negative 1. Well, y equal to negative 1 is going to be a line at negative 1. So, and I know it's going to be a horizontal line because why am I doing this? Why am I cross-country skiing? Okay, but it's going to be a dashed line. So at negative 1, we have our, I'm going to change this to black, we have our dashed line. Okay, we got to figure out what side to shade. So if I plug in 0, 0, is 0 less than negative 1? It is not. So I shade on the opposite side of 0, 0. Okay, this next one I could put a plus 0, so I'll have a point at 0. I could go up 2 over 1, up 2 over 1, up 2 over 1, or down 2 to the left 1. Down 2 to the left 1, down 2 to the left 1. Okay, this is also a dashed line because there's no line underneath my inequality. We cannot use 0, 0 because my line goes across it. So we could use 0, 1 to plug in. So this is my x, this is my y. So 1 is less than, or 1 is greater than 2 times 0. So 1 is greater than 0. That is true. So at my point 0, 1, which is right there, I shade on that side. So all of those points that are in my shaded region would be true if I plugged them in. Okay, match the graph with the equation. Well, first of all, it's a dashed line, so we know the inequality has to look like that. So we can automatically eliminate these. Now, if I plug in 0, 0, it's in my shaded region. So if I plug it in, it should be true. So I got, if I plug in for A, we're doing A, 0 is less than negative 1/2 times 0 minus 2. Is 0 greater than negative 2? It is. Okay, and since 0, 0 sits in my shaded region, and that's true, our answer is A. Okay, this one. First of all, we're shading on this side of this line. Okay, so it's going to be these second equations here. So if we're shading on that side, we can plug in, how about negative 1, 0, and it should be true. So this is x, this is y. So let's take A and plug it in. So 0 is less than, when I put a negative 1 in for a negative x, it becomes positive. Okay, so that is true. So we can eliminate all of them that have the inequality facing the other way. Okay, now we know this dashed line is all going up. So if I plug 0, 0 into the equation, it should not be true because it's not covering my 0, 0 spot. So I put it in for A. Is 0 less than 2? It is. So my answer is A. Okay, find the slope. Slope equation, m equals y2 minus y1 over x2 minus x1. Okay, so if I label my points, x1, y1, x2, y2, we're going to do m equals 2 minus 4 over 1 minus 3. 2 minus 4 is negative 2. 1 minus 3 is negative 2. Negative 2 divided by negative 2 is 1. So my slope is 1. Okay, so this one's 1 minus 1 over 3 minus 1. 1 minus 1 is 0. 3 minus 1 is 2. 0 divided by any number is 0. Okay, you can plug it into your calculator. You can check it. Remember, if 0 is on top, it is okay. Okay, negative 4 minus negative 2. Don't mix up your negatives on this. And then we got 3 minus negative 1. So this becomes negative 4 plus 2, because two negatives make a positive, and 3 plus 1. So we got negative 4 plus 2 is negative 2. Okay, and 3 plus 1 is 4. That reduces to negative 1/2. Okay, I'm going to go ahead and erase this so I have room for my next one. Okay, so this one we got 7 minus negative 1 and 3 minus 3. Two negatives make that positive, so I got 8 over 0. You cannot have 0 on the bottom. So this slope is no solution. Okay, find the equation and graph it. So we have a point and a slope, so point slope seems pretty easy. So y minus y1 equals m times x minus x1. So y minus 0 equals negative 2 times x minus 0. Got to distribute so we can get this equation. So I got negative 2x plus 0, so that basically goes away. If I add 0 to both sides, I'll get y equals negative 2x. Okay, if you wanted to graph it, you could do it two different ways. You could put your point at 0, 0, and then do the slope up to over 1, or you can go based on your equation here. But I asked you to find the equation, so you had to do that anyways. So we start at 0, 0, we go down 2 to the right one, down 2 to the right one, or up 2 to the left one, because it is a negative 2, so it should be decreasing. Okay, if f of x equals x plus 1, your domain values are 1, 3, 3, and 2. What is your range, and is it a function? Okay, so f of x means the same thing as y. If I have my domain values, that means these are all my x values, and I'm trying to find my range, which is my y values. So I'm going to plug them in for x. So we got plugging our 1 in. Plugging our 3 in, and plugging our 2 in. Okay, so one of my range values is going to be 2, this other one's going to be 4, and this one's going to be 3. Okay, so these are my y values. Okay, is it a function? My function, looking at this, my domain values, my x values cannot repeat because it will not cross the vertical line test. So, because I have repeating 3's, it is not a function. Okay? And what test can we use? The vertical line test. If I have the same x value twice, it's not going to pass my vertical line test because it crosses twice. So that means if I had a graph that looks like this, it's not a function because it crosses twice. Okay, so we got our domain values again, so let's plug in. So we got y equals 2 times negative 1 minus 1. Y equals 2 times 0 minus 1, and y equals 2 times 1 minus 1. Okay, so 2 times negative 1 is negative 2, minus 1 is negative 3. 2 times 0 is 0, minus 1 is negative 1. 2 times 1 is 2, minus 1 is 1. So here are our y values. Okay, what is my ranges? So that's what we found. It is a function. My x values do not repeat, so it is a function. Okay. Next question, if f of x equals 2x minus 1, what is f of 3? This 3 replaces the x. If f of x means y and we're replacing our x in this, we're going to replace our x in the equation. So 2 times 3 is 6. 6 minus 1 is 5. So f of 3 equals 5.